Hi everyone, welcome to today's episode of Your Data HQ. We have Sowmya Sundaram here with us today. Sowmya Sundaram is an AI researcher who is primarily interested in natural language processing and real-world applications of AI, especially in medicine. She currently works at the intersection of NLP and biomedical informatics research at the Stanford School of Medicine. She worked as a researcher for 2 years at L3S Research Center, Germany. She also received her PhD from IIT Madras. Her approach to science is to infuse creativity and elegance into pushing the boundaries. Thank you so much, Sowmya, for being here with us today.
Thanks, Sanjana. Thanks for the introduction. I'm so excited to be here and chat with a friend, to put it in short.
Very cool. So let's get started with how did you get into the data and ML space, and specifically, how did you go down the research path?
Yeah, that's an interesting question because what I was looking for is basically a typical kind of master's by project kind of degree after my undergrad. And when I applied, I also got selected for the PhD program. And I thought anyway, I wanted to do masters, and a PhD is going to be maybe slightly longer. That's how naive I was. I did not know what research meant at the level of a PhD, but I felt, and there was this really cool vibe around it that, oh, you got into direct PhD, it's this great thing. So I just entered it at like the age of 21, not knowing anything about it. And I basically thought it just meant that instead of spending 2 years reading books, I'd spend 4 years reading books. And that was not the case. And research was a completely different story than what I was used to. And in fact, the early part of my research did not involve machine learning, but as the computer science space evolved in itself, it became inevitable that if you are doing research and you are especially working on applications, then you have to do machine learning or data science or something to do with them. So, yeah, that's how I got into researching in the machine learning space.
That's very cool. And I can totally relate to that, shiny aspect of PhD once you're getting into it straight away.
Yeah.
And yeah. So what are some of the current problems or needs in the data and ML space that the community needs to come up with solutions to?
Especially after working in the medical field, I think there's a lot of distrust of machine learning algorithms, especially because with this huge boom of deep learning models which are not explainable, I think sensitive applications such as defense or medicine, there is an imperative need for explainability, and explainability cannot be something that we have in our academic circles that, oh, here are a bunch of attention weights, and we think probably this feature is important. But as somebody working in deep learning knows, even if we can figure out some feature that's important, probably we don't know what that feature means.
Yeah.
So, explainability is definitely one of the biggest challenges we have. And deep learning is not a magic wand we can just wave over every data problem that we have. The second problem is deep learning works only with large amounts of data. Even a lay person can understand that you'd be confidential about your medical data, and very less data actually comes up for research.
Mhm.
And what algorithms can we use? We end up using things that we used, say, 10 or 20 years ago. And how do we leverage what we have learned so far with less data? There's already a lot of research going on tabular data and low resource settings and so on and so forth. But it's still with a sense of, how do I make it work for deep learning? How do I augment this algorithm so that it works for deep learning? But that might not be the approach you need. And there is a gap in knowledge representation. And we see that often in medical data and other real world applications. So while text and images and videos, we have a lot of data, I think it's not the be all and end all. I think that's one thing we need to take care. The other big aspect I'm really interested in is ethics in data and fairness. And we see it often in news, in applications such as resume building and so on. how do we ensure that our algorithms are not biased, especially since it connects to the first point about explainability. If I can't explain how my algorithm is choosing things, then I don't know for sure if it is ethical or not. And ethics is also a problem because all data is biased. Data often comes from human sources, so it is going to be biased,
Yeah.
and that's a real concern. And I think what all of this means is we are going to need some kind of regulation of algorithms. We are going to have privacy issues and trust issues as we develop models that we put out there. And just like any technology that comes up, initially we're going to get burnt a bit,
Yeah.
but we'll figure out what to do with it in a positive way.
Yeah, but it's a great time to be in this field, or be an expert in this field, because there's so much we're figuring out. There's some standardization efforts, there's some interoperability efforts, and then, like you said, just a lot of efforts into enriching the data with context itself. Because, like you mentioned, right, it's not just about saying, I think this particular feature is important. For example, let's take sensor data. It's not like saying this sensor is important. It's about knowing why is it important and how was it related to the problem you're trying to solve. For example, maybe that's the sensor that is noticing for, like any sort of, let's say, earthquake in that region. Then obviously, like it's meant to, indicate an error if that sensor picks up something. So it's about going in as a human being solving the problem. How would you do it as a human being? What are the things you would notice, and then transfer that knowledge into the algorithm or the machine learning model. And yeah, that definitely starts with regulating the data, and then regulating the privacy, ethics, and context that the algorithm is focusing on as well. But it's a great time to be.
I have a small point to add there. Why I don't think it is completely important that the algorithm should behave as a human would or come up with
Mhm.
the same rules a human would. I
Yeah.
mean, it's always amazing if it figures out some patterns in the data that we did not pick up.
Mhm.
The point is, it should be explainable
Yeah.
and it should have some confidence intervals. And it's okay if it does something different, but
Yeah.
we need to know what it's doing. Yeah.
Yeah, absolutely. And out of the problems you mentioned that, we should be solving as a research community or a data community, what are the problems that your research group is focusing on right now?
Yeah, I'm happy and excited that I am working on some of these problems in a really small way. One of it is we work on evaluating the existing large scale NLP models for the level of understanding, to put it in a short way. So, level of understanding, I mean, we evaluate humans on how they understand language, and
Mhm.
we try to see if the existing large scale models that are really popular now, what level of cognitive understanding they are at. At the
Mhm.
end of the language models that are out there are really good text generators. And that's exactly how we need to see them. They're tools for text generation.
Yeah.
And we cannot see them as replacement for search, for knowledge, for mathematics, and so on. What it shows is, if at all it shows symptoms of success in these areas, it shows that language in itself has so many faithful patterns it can reproduce.
Mhm.
But what is the exact knowledge that's encapsulated can only be figured out by rigorous testing. And
Yeah.
we hope to publish some standards for that. So that's one piece of exciting work we do. The other thing is we are looking at metrics for measuring ethics in algorithms in the unsupervised setting, because I think supervised algorithms are really famous and people have real world implications instantly. For example, a recommendation system or a um, product that uses some data we can learn from. But there's also a lot of unstructured data out there which employ a lot of these unsupervised methods that are often neglected in the fairness space. So we look at metrics, and we also know the dangers of assigning a particular data set for these algorithms, because then the community just rushes to get better results on these data sets as if these data sets are the be all and end all of solving the problem. So coming up with benchmarks that make sense, because it's not like other AI tasks where we are looking at understanding or generation, but ethics takes it a notch above,
Mhm.
which requires tough metric formulation, and we need to rely on various discipline experts in ethics and in sociology, perhaps depending on the domain. So that's another piece of work I'm in. And the third sort of combined sort of this, which I'm really excited, which is that there is a lot of medical data out there, which are
Mhm.
very versatile, very diverse. And we use these NLP techniques to sort of bridge the gap between them. Say that one data set says gender in a particular way, and the other
Mhm.
data set a different way. How do I combine them? How do I say they mean the same thing?
Mhm.
And that's still difficult in a typical deep learning model, because these words may be misspelled, maybe coming from another domain, maybe having a different interpretation all on its own. So we use the pre-trained models in NLP, but we also use the domain knowledge in medicine to kind of unify data sets, because once we unify data sets, we have more data to work with. Right now, people release studies based on very disparate data sets, but if we can unify all of them for one particular disease or one particular type of gene, for example, we can make a more thorough study.
Mhm.
And the lack of metadata, spelling and description, and it's basically laziness, because data entry is something people don't focus on. We all focus on getting the result, getting the best algorithm, but while publishing the data, we don't spend so much time on describing it properly,
Yeah.
and that does not allow further research to progress well. So we're building a tool that kind of unifies data sets, and I think that's really interesting from all the perspectives I spoke about.
Yeah, I think that's very important to focus on the source of truth, which is what we use the data as, right? And like you said, we must look at LLMs, large language models, or something like ChatGPT, upon its ability to generate language coherently, intelligently, and using any other adjective. Uh, but ultimately, it's all doing that on top of the ground truth. ChatGPT is good because it had that massive source of ground truth with massive labeling efforts. And there's been a fad of going around in a lot of companies where everybody wants the next LLM, and it is possible, but not without massive amounts of context enriched data, and not without massive compute as well. So that's something to take care of. Yeah.
Yeah, and there are other concerns, right? Like climate and power and and things that we take for granted at this point in time.
Yeah.
And what does it imply? And as we've seen in the latest news reports, there are just millions of users pinging the servers and so on. So we have a lot of things that we need to keep in mind, which does not take away from ChatGPT and other LLMs how exciting it is. It is an exciting
Yeah.
zero shot kind of algorithm. But we still have a lot of concerns that we need to be careful of.
Yeah, that is definitely true. So, what would be your advice to a team that's trying to achieve an ideal mix of publications and implementations?
I think if we have a team for that, it's important to know roles. I'm actually experiencing this in the team I'm working currently, where we have a good mix of software engineers and researchers who have great communication between them. I think what happens is in a lab, either it becomes too paper oriented, research oriented, or too implementation oriented. And the reason that happens is the language they speak are different.
Hmm.
And researchers focus on producing more novel results, while engineers focus on using results that are useful and relatable and can be produced at scale. So these are very different goals. So how do we bridge the gap? So the way our group does that is the engineering team works on a slightly modified version of the problem, and the research team works on publishing novelty. So
Hmm.
that way, the engineering team is supplied with modified versions of the algorithms that will scale and generalize, whereas the research team focuses on the novelty and pushing the boundaries of things that possibly don't even have an application at this point
Yeah.
in time. So it's fine. It's good to have that separation, and the way the team works. And I've learned a lot from this team in just the 3 months I've been here. That we work on good collaboration. We have people from all kinds of backgrounds, and software engineers publish in conferences, and researchers go and talk about products in product launches, and that kind of synergy has been really exciting for me.
That's awesome. That's actually a very good, I think, trend that's coming up, that you have to sort of balance between the research and pushing the boundary stuff, and sort of knowing when the boundary need not be pushed, and it's okay to like jump to implementation now. And the industry, especially NLP side of things, is moving at an extremely fast pace. So it's okay to like keep pushing it out and iterating and getting the next best thing out. So,
Absolutely, yes.
yeah. So, as a researcher in academia, what would be your advice to students in this field?
So if you're a new PhD student, so I think it differs at what degree they're pursuing. I think it's never too early to start dabbling in research.
Mhm.
I think if you're in undergrad and you're taking your basic courses, it would be great to look at papers that were pivotal in the field or the latest ones, and just try and get what's happening. It can be very jargon filled in the beginning, that you don't get what's happening. So it's nice if you've learned the concept and you're seeing the paper associated with it, then you can make the connections. And at a PhD level, I would say always go after problems that are kind of new. So that way you don't have, so it shouldn't be completely new that you are the pioneer in the field, because you're just starting research and you don't have the intuition to work on such problems. But ideally, you'd start on a problem that has some amount of work but does not have a huge body you need to
Mm.
compare against. And that's where your advisor and guide can help you with that. And I would also recommend to attend as many conferences as possible, especially in today's remote kind of
Yeah.
settings where there are more opportunities. And start publishing, say, workshop papers, or starting small so that you get that confidence that you can publish more. And anything, any software demos. There are even PhD consortiums and doctoral colloquiums where you can present your thesis ideas, and basically getting used to the idea of presenting, because that will give you a lot of voices and reviews apart from your advisors or your lab, which can easily become a bubble. So it's really important to get voices from outside.
Yeah.
And the best way to improve your work is just submit it to like A-star locations, get reviews, and develop a thick skin for rejections. It's easier said than done. I completely admit it. Even now, when I see a rejection, I'm like, this isn't fair. But it's part of the game, and I think far more than the IQ required to do research is the
EQ.
EQ to just persevere and keep doing things. And I don't think, from my personal experience, that the most successful PhD isn't like the one who has the smartest ideas, but it's the one who persists, who submits, who markets, because at the end of the day, you need your citations. So it's also about marketing in
Mhm.
some way. People don't think of academics as people who market, but you need to market your ideas so that you get feedback and you don't sit in an ivory tower that, oh, I'm doing this all on my own in this tiny place, and this I will talk only with my advisor or only with my lab mates, and that's not going to be good research.
Mhm.
So, and by good research, I mean, anyway, we are going to go to peer review stages in the review stage, but it's good to develop a culture earlier on.
Yeah.
And I think the last advice I would have is to read the concepts from the basics. I think in this entire publish or perish kind of culture, there's this temptation to read the latest paper, implement it, see what's wrong with it, and just improve a delta version of it and submit it. But I think while that's good to have a starting point, it's also important to spend some time understanding the basics and understanding why this algorithm came here in the first place. What was the problem that historically couldn't be solved that this paper is solving, that it's so popular? And if we don't have that idea, more often than not, we'll end up either reinventing the wheel or developing something that's going to get outdated in like 2 months. So it can get depressing if you're having these parts and ideas that are not completely well baked. But at the same time, I think you shouldn't get into this perfectionist tendency where you're like, only if I completely understand every bit of what's happening, I will publish. Because sometimes experimentally, something will happen that you cannot explain theoretically. And literally, entire deep learning is going like that, where we are proven by experiments and not by theory. And so it's important to have both. And I think, like, to summarize, I would just say just persist and not lose hope, and also not fall into the trap that I'm not smart enough or I'm not persevering enough and those kind of things. And look out for collaborations, because when you feel down, when you feel like things can't be done, I think collaborating with people, wherever possible, can help.
Yeah, got it. I can imagine how hard it should be for students to, keep track of the entire trajectory of research in that particular field, to know why we're doing what the industry is doing right now or what the academic community is doing right now. But I guess that's just part of the job. And like you said, like they don't have to fall into that perfectionism, because there is empirical evidence that can also bring out good research.
Exactly, absolutely. And there are often these trends that happen that right now working on LLMs is the thing. But we've seen it happen time and again. Before that, it was SVMs, or
Yeah.
before that, there's some other technology. So technologies will come in and go.
Yeah.
But the idea of research is to go after new ideas and push the boundary even a little bit and be comfortable doing that.
Yeah, got it. And you mentioned that it's never too early to start researching. Would you say that there is a point in time where it could be late to start research?
Oh, no, I don't think so. See, I think research is just like any other skill.
Mhm,
You might have practical difficulties in terms of, like, say you want to be a professor or something.
mhm,
Then, yes, there you would have some, say, age restrictions or something like that. But in today's democratic internet era, nothing stops you from researching, from publishing. It might seem intimidating for someone from the outside who has never experienced it. It was intimidating for me as well when I started, and all my seniors in the lab were publishing, and I had no idea what that meant. And the whole idea of creating something that didn't exist frankly scared me, because until then, the education system had trained me to just reproduce things that existed before. And this idea of creating something that doesn't exist, that should not exist before, I mean, it's a hard condition
yeah.
for was really hard for me to reconcile. It was exciting because
Mhm,
I thought it's a challenge and all of that, but I was clueless how to do it. But it's not as um, hard as people sell it. In the sense, it's hard because it's new.
mhm,
But apart from that, I don't think it's a skill that's beyond practice. And I think it's about getting an intuition of things you're working with, especially in machine learning. You get a feel, if I may say, of how the data works, how language works. I've started noticing so much in linguistics and how we speak because of all the work that's been happening, and how language, affects society. And I think being eternally curious is the only uh, prerequisite you need. I don't think it's ever late to start researching. And I do think we need more researchers who will just share what they think of what's happening and not be bogged down by, H index, how much paper is
yeah.
being published, and so on and so forth. So I don't think it's ever too late or too early to start. It's just, let's just explore, and every voice counts.
Yeah, that's very inspiring. Thank you very much, Sowmya, for this amazing interview. We definitely do have a lot of work to do in the data and ML and NLP space. But I would say this is one of the most exciting times to be in, with like the overall exposure of, the research that's going on, the amount of coverage it's gotten, even in the, non-tech world. It's amazing, and it's a great time to be. Thank you very much.
Absolutely. It's been absolute fun and a great break from tedious work. And I think that's really important to kind of mix things up a bit.
Cool. All right. Bye-bye.
Thank you. Bye.